YouTube channel. I am Shlok Kulkarni, and today we are going to cover a very important chapter from Oxford and RK Bali Radio Navigation. Today at this particular lecture we will be doing RK Bali Radio Navigation VOR questions. So there is a chapter called VOR, RMI and ADF related questions. So we will be particularly targeting questions from that chapter. To do these questions, I have also made, you should have a proper theoretical understanding of the concept. So I have also made a separate detailed video on the theory of this VOR and how to approach the VOR sums in that theory. So do watch that video, get familiar with the concept, the understanding, what is expected from you, what questions and will be asked in the exam. I have explained all that in that particular video. After watching that video, you can come here and start with the questions directly. So question number, so to begin with, so let's start with first question for today, which is question number 27 from correction from RK Bali. Question number 27 from RK Bali. So it states that aircraft heading is 225, ADF RMI reading is 090. The quadrantal error of this bearing will be what? So will it be not much, negligible? Will it be proportional to sign, heading, times signal? And will it be maximum? So now quadrantal error. Quadrantal error is one drawback. Quadrantal error is one drawback, okay, of headings. Okay, this error is discussed in detail in NDB ADF chapter. So that is a drawback of that NDB also. So quadrantal error is faced in quadrantal directions. So what directions we have? We have four cardinal directions: north, south, east, and west. Right? So along with these four cardinal directions, we also have another four quadrantal directions. Another four quadrantal directions, which are northeast, northwest, southeast, and southwest. So at this quadrantal directions, if your aircraft has a particular heading, there will be a quadrantal error experience. And only at this four quadrantal directions of northwest, northeast, southwest, southeast, the quadrantal error will be maximum. And therefore, the question which states that about the quadrantal error is that the heading of the aircraft is given to be 225 degree is given 225 degrees magnetic. Now 225 degree is somewhere in the southwest sector. 225 degree is in the southwest sector, properly in the southwest sector, and that is where the quadrantal direction also lies. And therefore, if your aircraft has a heading of this, quadrantal error experienced by aircraft will be maximum. Okay, let's go to question 28. Aircraft is flying a constant heading with 8-degree right drift or starboard drift and is making a good track parallel to the center line of an airway, but 5 nautical miles to the left of the center line. But 5 nautical miles to the left of the center line. We are told to find the relative bearing, okay, relative bearing of aircraft with respect to the NDB which is ahead of it. So I will just draw the diagram. So here is your NDB, okay, right, and over here is your aircraft, the position of aircraft. Now they say the distance off track is given 5 nautical miles and the distance remaining to go towards NDB is 42 nautical miles, right? And now we are told to find relative bearing. Now relative bearing is always between heading of aircraft and and track towards the station, that is QDM, track towards the station. Okay, so now what information we have? We have a constant heading, we have starboard drift, and we are 5 nautical miles. So let's talk about this. Now when we have a constant heading, so for the purpose of this example, assume the heading of aircraft, the heading of aircraft is 090 degrees. Now whenever there is a starboard drift, we have covered this concept in detail in 1 in 60 rule questions. I have also made a detailed video lecture only on drift, in which I have explained starboard drift, port drift, what happens under those conditions. So if you have not watched that video, watch that video. After watching that video, this will be easy for you. So when you talk about starboard drift, the heading will be less than the track. Now the heading we have assumed is 090. Okay, so if heading is 090, definitely track will be more than that, but more than heading by what value? So the value is given 8 degree, 8 degrees starboard drift, right? So therefore, if heading is 090, track will be equal to 098 degree, which is 8 degrees starboard drift. So track will be more than heading by 8 degree. So this is your track, okay, or magnetic bearing to the station, which is 098 degree. Okay, so this is step number 1. Okay, with respect to the drift, our magnetic bearing to the station is 098. Now along with this track, we have other information which is given to us about this 5 nautical miles and 42 miles. So with this information, we can find out the closing angle. So we can find out closing angle. So closing angle will be equal to distance of track divided by distance gone into 60. So distance of track is 5, distance gone is 42 into 60. So that will be equal to 5 into 60 divided by 42, which is 7 degree. So closing angle is 7 degrees. Okay, so closing angle is 7 degree. Alternate angles are equal. So if this is 7, this will also be equal to 7 degree. Okay, so now this is 7 degree. Now if closing angle is 7 degree, the track towards the station should be corrected accordingly. So now track, we have initial track 098 degree, and now we want to have a track of towards the station will be 098 plus 7 degree, which is equal to how much? 98 plus 7 is 105 degree. 105 degree. Why have we added this 7 degree? Because the original track was how much? With respect to drift, 098. Okay, 098 was the track or QDM or magnetic bearing to the station. 098, if this is your station, so 098 was the track towards the station. Now with respect to, okay, with respect to the distance of track, we have deviated off track by some nautical miles. So due to that deviation, we have to calculate a new QDM or track towards the station. So we are at currently 098 track. When you add this step 2 also, okay, when you add, why are we adding this? Because we have to make a right turn, right? So when you add that, the new track to the station becomes not 098 but 105 degrees. It becomes 105 degrees. Okay. So this is your final magnetic bearing to the station. This was your initial magnetic bearing to the station. So always in such questions, first calculate magnetic bearing to the station with respect to drift like this. After that, calculate final magnetic bearing to the station considering closing angle or whatever other angle is given. So now relative bearing. What is relative bearing? Relative bearing is the angle between your heading and magnetic bearing to the station. Now in this case we have two magnetic bearing to the stations. We will consider that magnetic bearing which is final. Excuse me. Okay, which is final. Okay, so final magnetic bearing to the station which is inclusive of this initial part and this final part, both the values. So now what is your heading? So the formula is magnetic bearing to the station is relative bearing plus your heading, right? So magnetic bearing to the station is 105 degrees. Relative bearing we have to calculate. Heading is, we have considered heading 090 degree. So relative bearing will be 105 minus 090. So relative bearing will be equal to 015 degree. Relative bearing will be equal to 015 degree. So this is how you do it with the help of the sum. Okay. Next. With the help of diagram, I will also show you how to do it with the help of diagram. So I will take a new screen, new slide. So we have our NDB station somewhere here. We have a final magnetic bearing to the station of 105 degree. 105 degree is your QDM. Okay, on that track, our heading is less than 105, which is 090. Okay, let's say 090 is somewhere here. 090 is your heading. Okay, so this is your track. This is your heading. Relative bearing is the angle between, remember these words, relative bearing is the angle between your heading and the track. What kind of track? There are two tracks possible. The track that takes you away from the station and the track that takes you towards the station. So the track here we are talking about is one which takes us towards the station, or also known as QDM, magnetic bearing towards the station. Okay. So over here the heading is 090, track is 105 degree. Now relative bearing is the angle between heading and track, and it is measured clockwise. Always measured, directions are always measured clockwise from the heading. So look at this. So you will start from heading to NDB. So like this, right side starting from the heading towards the NDB. Now the thing with relative bearing is that when you measure a relative bearing, you don't measure that direction, that relative bearing angle with respect to magnetic north or true north, compass north. No. Unlike other directions, relative bearing is measured starting from the longitudinal axis of aircraft. Okay, starting from the longitudinal axis of aircraft, not with northerly heading or true north, magnetic north, or compass north. Okay, with respect to relative bearing, the starting point is, or the datum is, your datum is longitudinal axis of aircraft. Longitudinal axis of aircraft. So that is the starting point or datum. So now longitudinal axis of aircraft, just for relative bearing, let's say this is your longitudinal axis of aircraft, the direction in which it is heading. So that is the starting point. So the angle there will be 000 degree. Now start measuring your angle from 000 degree right hand side. So we know this is 090, this is 105. The difference between them is 15 degree. So this angle starting from 090 to 105 will be 15 degree. Okay, relative bearing will be 015 degree. Okay, so difference between this track and heading is 015. Relative bearing starts from 000, 001, 002, 003, 004 up to 015. Okay, so 15 degree is your relative bearing angle. So diagrammatically you represent it like this. Okay, with help of diagram also you can quickly guess the answer, or if you want to use the calculation, which is magnetic bearing to the station is relative bearing plus heading, substitute the values, you get the answer. Okay, so first find the initial magnetic bearing to the station. Then with respect to the distance of track given to the in the question, find the closing angle and then add or subtract that angle to get or obtain your new final bearing to the station. So this will be final track to the station. Next question, question 29. Aircraft is flying on a heading of 270. The VOR OBS is also set to 270 with full left deflection and from flag is displayed. In which sector is aircraft from the VOR ground station? When considering VOR questions, VOR as a whole is only concerned about your position. VOR is only concerned about your position. It is not concerned about your heading. Whatever heading of your aircraft, okay, irrespective of that, the radial that you are situated on is indicated to you. Okay, you may be flying on a radial, you may be flying on a radial of 090, and yet your heading can be anything other than 090. Okay, let's say your aircraft heading is 360. Okay, so that doesn't matter. Your VOR will show you radial 090 in the instrument. Okay, the heading of aircraft doesn't influence or affect the operations of VOR or the functions of VOR. Okay, the only thing that is important for VOR is the OBS selector. Is the OBS selector. So it's like a round instrument, and there is an OBS knob. Okay, in the instrument there are numbers 0, 30, 60, 90, so on and so forth. Okay, these numbers are there. Apart from that, there is a small window in which to from indication is written. Okay, and with this OBS knob you can rotate it clockwise, anti-clockwise, and you can insert or give an input of any number or direction you want to be situated at. Basically this OBS knob will help you to put the radial you want to fly at with respect to VOR. Okay, so that is so whatever radial you put, that will be on the top. That will be on the top. Okay, with the help of this knob. Okay, so what input you give in this OBS selector, accordingly that number will come on the top, that direction or the radial number will come on the top. Accordingly to from indication will be shown to you, and then there is also a CDI needle. There is also a CDI needle. Accordingly that CDI needle will move left or it will move right. Will move left or right depending whether you are correctly on the radial or left of it or right of it. Okay, so the VOR OBS is 270. So the pilot of this aircraft has set his OBS selector on 270 degrees. Okay, so let's draw the VOR. This is your VOR. So this is your radial 270. Whenever you draw a radial 270, also draw the reciprocal of that, radial 090. Okay, next information given to you is a from flag is displayed. Okay, in the VOR OBS selector, a from flag is displayed. Now the job of radials, primary job of radials is to take you away from the station. Away from the station. The primary job of radials is to take you away from the station, VOR station. So if I say I am flying a radial of 0900, that means following this radial 0900, I am flying outbound. Or if I say I am flying a radial of 270, it means that you are following this radial 270 and going outbound from this VOR. Outbound means away from this VOR. Okay. So next, there is a full left deflection. There is a full left deflection. In which sector or in which quadrant are you located? Now, let's take, there are two conditions I want to deal with. So, condition 1, let's say there is no deflection of the CDI needle. The CDI needle is right in the center. The CDI needle is right in the center. That means the aircraft is flying correctly on the center line of this 270 radial and flying outbound okay, it is flying and on the center line flying outbound, so the CDI needle stays in the center, in the middle of the instrument. Okay, so that is condition 1. When CDI needle is centered, so which means aircraft is on the center line of the radial. Now condition number 2, which is given in the question. Condition number 2 is given in the question that CDI needle, which is the CDI needle has moved to the left hand side. CDI needle is showing full left deflection. Okay, left deflection. So if the CDI needle is showing you, if the CDI needle is showing you a full if the CDI needle is showing you a full left deflection, that means your aircraft is not on the center line of the radial, it is to the right of it. What is the job of the CDI needle? It is to tell you whether you are to the left of the center line or right of the center line. Okay, but it doesn't give you this information directly. It gives you the solution. The CDI needle gives you the solution to the problem. Okay, so the solution is given by the CDI needle that it has moved left. That means your aircraft should fly left hand side. Now you will fly left hand side only and only when you have deviated to the right hand side. Correct? If the CDI needle moves to the right hand side, now CDI needle is your solution. So what is the problem here? If the CDI needle has moved right hand side, that means your aircraft has deviated to the left hand side. Okay, so in this case CDI shows full left deflection. That means from this information what have we derived, what conclusion do we derive? That our aircraft is to the right of the radial selected in the OBS. Okay, that means aircraft is to the right of the radial which is selected in the OBS. So your goal or your purpose was to fly along this radial 270. Okay, if you are successful at that, the CDI needle stays in the center and you continue flying like that. If you deviate left or right from that radial, you will get the left and right deflection reflected on the OBS selector in the form of CDI needle. Now if there is full left deflection, that means your aircraft is to the right, somewhere to the right of radial 270, somewhere to the right of radial 270. Okay, so now what sector is this? This is your north direction, this is your south direction, this is your west, and this is your east direction, right? This sector between north and east is your northeast sector. The sector between your south and east is your southeast sector. The sector between south and west, southwest, this becomes your northwest. So the correct answer is your aircraft is currently in the northwestern part of the coordinate system. So option C is the correct answer. Let's go to question number 30. If ADF indicates 200 degrees and RMI is stuck at 090 degree, what is the relative bearing of the beacon? What is the relative bearing of the beacon? Now there are two concepts of ADF. If there is only ADF mentioned in the question without RMI, any mentioning of RMI, that means this ADF will directly give you relative bearing. But when the question states ADF and RMI both together, in such a case, in RMI instrument, you will directly receive QDM to the NDB. You will directly receive the QDM to the NDB. So this is how your instrument look. You must have seen it in Oxford or any other books, even in RK Bali it's given. So RMI is a combination of your magnetic compass, and also on it is displayed information of VOR, radial, QDM, QDR of VOR, and QDR of NDB. So magnetic heading is represented on the top, and then there is an arrow like this. Now the tail of this arrow and this head of this arrow. So head is your QDM towards the NDB. The tail will be your QDR. Okay, so directly when you use RMI, you will be directly given the information of QDM or the direction that you need to follow or track towards the NDB station. In a simple automatic direction finding equipment like this, you will just have an instrument like this, okay, and there will be numbers 0, 30, so on and so forth, fixed numbers everywhere, 360-degree, and there will be one needle which will point at one particular number. The direction in which it points is your relative bearing. So a simple ADF instrument only tells you about your relative bearing. But RMI is more advanced than ADF. Instead of giving you relative bearing, it directly tells you the QDM that you have to fly to go towards the NDB station. Means what? The QDM which is directly given to you by the RMI is a combination of relative bearing and magnetic heading. In aircraft, you don't need to do that addition subtraction. It's directly given to you in the form of QDM by RMI. If you are using this simple instrument, then you will have to add relative bearing to your magnetic heading or the compass heading to find a QDM to the NDB station. So here ADF and RMI are given. So what will you do? So when ADF and RMI is given, that means they have given you directly, they have given you the QDM towards the NDB station. So QDM to NDB is equal to 200 degrees. Magnetic heading is how much? So RMI rows. RMI rows means this top portion. Okay, where any number is there according to the heading you fly. Okay, it's 090. So what is relative bearing? What is relative bearing? So the formula, as you know, QDM equals to magnetic heading plus relative bearing. So 090 plus 200. So that is 290 degrees. QDM is 290. Option A will be your correct option. Diagrammatically, how will you represent this? So let's say this is your NDB. Okay, NDB station. The track to the NDB station is 2 0, 0, which is reciprocal of 0, 2, 0. So QDM 200 magnetic heading is 0900. Now relative bearing is the angle between your magnetic heading and your QDM, that is your track towards the station, measured from the magnetic heading, measured from the magnetic heading. So now this is 0900 and this is 200. So always relative bearing starts from the longitudinal axis of aircraft. So this is your datum 00 degree. So starting from 000 right hand side. So this angle will be how much? 200 minus 90, which is 110 degree. So option is B. Correct this. So QDM is 200, heading is 0900, relative bearing we have to find out. So relative bearing is 200 minus 90, which aircraft is on radial 240, aircraft heading is 230. CDI shows 2 dots fly right and to and from indication shows 2. What is the OBS setting that you should put and what is the type of sensing that is experienced? Okay, normal, reverse, accordingly. So I will use a new slide. So aircraft is on radial 240. So there are two conditions. Being on radial 240, this is your VOR station. Being on radial 240, this is again another condition. Scenario number 2. This is your radial 240. Now you can fly along this radial 240 and go outbound and go outbound. Okay, away from the VOR. You can fly along this radial 240 and go inbound and go inbound, that is towards the VOR, towards the VOR. Okay, so there are two conditions that is possible, going towards the VOR or going away from the VOR. So if you want to go away from the VOR, okay, on radial 240, you will put in your OBS selector the what number will you put? You will put 240. When you put 240, you will get indication from. If you want to go towards the VOR, so in your OBS selector you will put, if you want two indication in the OBS selector you will put the opposite of radial 240, which is 060. Okay, radial 060. Okay, which is opposite of radial 240. So you fly along this radial 240. You are on radial 240, but you have put radial 060 in the OBS selector. Only that case, in that case only you will get normal sensing. Okay, if you are going towards the VOR and still you put radial 240, you will get a reverse sensing, because if you put radial 240 you will get a from indication here, but as a pilot you are going towards the VOR, so you want all CDI needle left and right indications with respect to going towards the VOR. If you put 240, you will get all CDI needles which show from indication, okay, from that point of view. So that will give you reverse sensing. So if CDI needle goes left, you will have to fly right. If CDI needle goes right, you will have to fly left. Okay, so to evade that, if you're approaching VOR, put the radial opposite of 240, so you get two indication and correct sensing. If you're going away from the VOR, put the radial, you will get from indication, correct sensing. So these are the two scenarios, scenario 1 and scenario 2. Now the question states you are getting two indication. So in the OBS selector, in the OBS selector you will put what? You will put 060. Okay, and the type of sensing. If you are getting two indication, your OBS selector should be 060 and you will receive a normal sensing. Okay, next, the two dots fly right. Now this is the ideal scenario in which you are correctly established on the radial towards the VOR. Now if the CDI needle tells you fly right indication, that means your aircraft is somewhere to the left of the 240 radial. Aircraft is to the left of the 240 radial. So I am drawing this diagram again. This is your VOR. This is your correct radial 240 where you are expected to be, but you have deviated left of it somewhere here. Now I know the heading of aircraft is 230 and 230 is not in that direction, but VOR is not concerned about heading, your position. Whatever you are heading, the position, your radial that you are situated on is what matters. So aircraft is somewhere to the left of radial 240. Okay, going towards the VOR, and therefore your CDI indication tells you to fly right, to fly right. So the CDI needle will go two dots right hand side, two dots right hand side. Okay, so this is how you do the sense. The OBS selector that you should select is 060 towards the station, and the type of sensing will be normal sensing. Okay, so if you are the next, I will also explain to you next. Now in localizer, one dot equals to 0.5 degree. So two dots will be equal to 1 degree. So that means if the indication is fly right, two dots fly right, that means it is telling you you are deviated by 1 degree. So you are deviated 1 degree left. That means you are on radial 241. So the opposite of radial 241 will be radial 061, and opposite of radial 240 will be radial 060. So draw the opposite directly. But that is not required. So up to here, OBS selector is 060, type of sensing is normal sensing. Question 32. Aircraft heading is 080. OBS you have selected at 060. Aircraft is currently on a radial of 040. So this is your VOR. This is your radial 040 where the aircraft is situated. In the OBS selector, you have selected radial 060. So 060 will be right of radial 040. Okay, and the two from indication will show what? So you are on radial 040. You have selected radial 060. The job of radials is to take you away from the station. Now the fact that you have put radial 060, that means you want to change your radial from 040 to radial 060 and then fly along the radial 060 outbound. Okay, so the correct indication will be what? It will be from indication. Okay, and CDI needle will move in what direction? You want to go from 040 to radial 060, which is to the right hand side. So the CDI needle will move fly right, and indication will be from indication. So 32 answer is option A. From indication, fly right, because the radials you have put, radial 040 and radial 060 are on that side of the VOR. So therefore from indication. Okay. Next. Question 33. Aircraft is heading 055. RMI reading 060. So RMI directly tells you about QDM, that is magnetic direction of bearing towards the station. After some time RMI reads 057 with no heading change. So aircraft ka heading before which was 055 has remained constant. Okay, what has changed is QDM has changed from 060 to 057. Heading stays constant. Aircraft has drifted in what direction? Whether the aircraft has drifted to the right hand side or left hand side. Okay, that we have to find out. So now there are two conditions, condition 1 and condition 2. So in condition 1, let's write the formula. Magnetic bearing to the station, which is your QDM, you all know that, is your magnetic heading plus relative bearing, right? Substitute the values. QDM initially was 060, heading is 055 and relative bearing is, we don't know. So relative bearing is equal to 060 minus 055, which is 005 degree. Now let's go to scenario number 2. Same thing. Magnetic bearing to the station equals to QDM equals to magnetic heading plus relative bearing. So QDM, new QDM is 057. Heading is 055. Same heading. So relative bearing will be 002 degree. So relative bearing has changed from 055 to 002. 055 to 002. So that means, let's draw this. I will draw this. This was your station. Initially, this was the track to the station 060 and heading is 055. Heading is 055. So relative bearing is what? Relative bearing is 005 degree. Okay. So aircraft and station. Now, okay. Now, in next scenario, we have the same station. Okay. And track is towards the station 057. Heading has become 005, same, but the relative bearing we have found was 002 degree. So that means, this means what? There is some kind of relative bearing is what? The angular difference between your heading of aircraft and the station. So if relative bearing decreases, that means the angular difference between your aircraft heading and the station also decreases. So that means somewhere the aircraft is coming closer and closer to the station. So that means if directions are decreasing, okay, like this from 5 to 2 degree. So as the direction decreases, that means there are some winds from the left hand side pushing aircraft to the right hand side. And as a result of that, the angular difference between the heading and your track towards the station is decreasing. If there were winds coming from right hand side like this, so the aircraft would have drifted away to the left hand side away from the station. But now what we have observed, relative bearing has decreased. So that means somewhere the angular difference or the distance between the heading and the station, the track towards the station is decreasing. And that can only happen when there are some winds coming from the right hand side pushing your aircraft towards the track, towards the station, or towards the track leading to the station. Okay. So if the winds are coming from right hand side, they will drift you left. So winds coming from right hand side will drift your aircraft to the left hand side. Winds that come from left hand side will drift you right hand side, right? Will drift you right hand side. So in this particular question, the winds are coming from the left and they are drifting you towards the station. Okay. So the correct answer here will be aircraft has drifted right hand side or starboard or starboard side. Okay. Right hand side or starboard side. So this is how you do it. Relative bearing you have to remember. Okay, relative bearing you have to remember. So this is where the key to the solution lies. Relative bearing is decreasing without the change in heading. So that means there is something that is taking you closer towards the station. Relative bearing is angular coverage or difference between your heading of aircraft and the station. Okay, track towards the station. Okay, so if that angular difference is decreasing, that means there is some external force that is pushing you towards the station and hence decreasing the separation or the angular difference between your aircraft heading and the station. So that is only possible with the help of winds coming from the left hand side drifting you to the right hand side. Okay, why is that? Because here it specifically mentioned there is no heading change. So there is no scope of heading change. That means there is only some external factor which is bringing this result. So with this we come to the end of this lecture. I hope you are comfortable in answering VOR questions now. So keep practicing, keep learning, keep watching these videos again and again till you gain confidence in them. If you have any questions or any feedback, let me know in the comment box. All the best. Subscribe to this video and share this video with all your friends. Thank you.